if I give you a graph, can you figure out what the equation is? For simplicity's sake, for all of these, we're going to have our C value equal to 0, because if we can move our graph left and right, it opens the doors for a lot of possibilities that we don't really need to get into right now. So that means that we are going to be writing equations y equals a sine bx or b theta plus d, or y equals a cosine bx or b theta plus d. All right, so we have to figure out if we're using sine or cosine. We need to figure out what our a value is, our b value is, and our d value. Reminder, these are your basic sine and cosine graphs. This graph crosses the y-axis right here at -3. Notice what's happening with this graph. This isn't our peak or the trough, I think is the right word if you're talking about wave functions. This isn't the top or bottom of our wave. It's somewhere right in the middle. So based on our graphs here, cosine always crosses the y-axis at the top of a wave, or if we had a reflection, it would be at the bottom of a wave. Sine is going to cross in the middle of our wave, regardless of whether we have any kind of reflection or not. So that tells us that this is a sine function. All right, sine always starts in the middle of our wave. Well, we've just decided that it crosses at -3. That is the middle of our wave, so my d value is -3. All right, let's figure out our a and b values. A, from this center line to the peak, or from this center line to the base, how far is that? That's what our amplitude is. That's what our a value is. So 1, 2, 3, 4. This is 4. And the same thing here, double check 1, 2, 3, 4. They should be the same. This is a 4. Is it positive or negative? Well, your basic sine graph crosses the y-axis and then goes up before it comes down. This graph also goes up before it comes down. So this is a positive a. And then the last thing we have to figure out is our b value here. Okay, so for b value, basic sine graph starts at 0, goes up 1, back to 0, down 1, back up to 0. This is the shape of a basic sine graph. From 0, normally basic sine graphs go from 0 to 2 pi, but this one goes from 0 to pi. So whenever we are trying to figure out your b value, we're going to use the period function. Remember that was 2 pi over b equals my period? Well, my period here is pi. It takes this whole shape and it's only a width of pi. So 2 pi over b equals, this is my new period. So my original period over b equals the new period. And now we're just going to cross multiply to solve for b. You can write anything over 1. That way it's a little bit clearer when you're cross multiplying. So 2 pi times 1 is 2 pi. Pi times b is pi b. Solve for b, so I need to divide my pi over to the other side. And when I do that, the pi's cancel, and I'm left with 2 equals b. You can always graph this in your calculator if you have a graphing calculator, so you can double check your work. Or you can go to Desmos.com. We've used that a lot to practice activities. And you can type this in and double check that your function shows up. If you're going to type this into your calculator, when you turn it on, you might want to press the window and go from -2 pi to 2 pi. So now when I type in my equation, 4 sine 2x minus 3, we're in degree mode. Change your mode. Now when you graph, there we go. This looks like, or should look like, that to double check that we're on the right track. You can change your y values on your window to make it zoom in perfectly the same way we have on this video, on this graph. Okay, so before we move on to the next one, let me just talk about some recaps real quick. Whenever we're doing this, we need to figure out if this is a positive A or a negative A, and we have to figure out what the A value is. Our B value, for simplicity's sake, should always be positive, because a negative B for a cosine is just going to flip it over the y-axis, and it's even symmetry anyhow, so that doesn't matter. And a negative B for a sine looks the exact same as a negative A for a sine. So let's always have our B values positive, just for simplicity's sake. You could make some negative if you want, but then you wouldn't use your negative with the A. And then last, the D value, I think, is the most straightforward one. Positive or negative just moves the whole graph up. And then, of course, I forgot to mention this. You should pick, are we using a sine function or a cosine function? So it's 4 different things you kind of have to pick out. And when you look at each piece, you need to figure out if it's positive or negative or implied to be positive. But we can totally do this. You just need to take it a little bit at a time. Let's do another example, though, to help clarify and cement the ideas in your mind. Okay, so this graph, we are at the bottom of our wave when we cross the y-axis. Sine graphs always cross the y-axis right here in the middle of your wave. Cosine can cross at the top or bottom. So because we're crossing at the bottom, this is telling us that this is a cosine function. And because it's at the bottom and not the top, top is normal, this is a negative A value. Okay, we're at -1 all the way up to 3 is my peak here. So what's halfway between -1 and 3? So if I go 1, 2, all right, so right here is the very center of my graph. That is at +1. And from 1, I had to go up 2 to get to my peak, or go down 2 to get to the bottom part of my wave. So 2 is my amplitude. All right, B. Remember, your normal period of a cosine function is 2 pi. So if I divide it by B, that should equal my new period. Or also, this is the formula for period anyhow. Normal cosine graphs start at the peak of the wave, they go down and then come back up. This is a period in a normal cosine graph, 2 pi. Well, this time we're going to start at the bottom of our wave, but to go through a full cycle here before we come back down to our bottom of our wave, that happens at 5 pi over 4. Kind of hard to see, but that is 5 pi over 4. I will make it clearer if we do this on classwork or a test. All right, let's cross multiply. 2 pi times 4 is 8 pi. 5 pi times b is 5 pi b. Divide by 5 pi because we want b by itself. And our pi's cancel out or simplify to 1. So my final answer, well, my answer is b equals 8/5. You can double check if I already have my calculator set up in radian mode, and my window is from -2 pi to 2 pi. All right, if I type this equation in and hit graph, I'm not zoomed in enough y-axis wise, but it looks like that is the graph that we have shown. So yay.